Taboo Science.
When you have a new baby, poop becomes something you think about a lot. I mean, not just the babies either. Pooping in the days and months after giving birth is a pretty wild ride too. But yeah, mostly the babies. When they first come out, this perfect little newborn starts filling their tiny little diapers with stuff I've only seen in The Exorcist. It's blackish green and super sticky, so it's nearly impossible to wipe off of their delicate skin. After a few days of drinking milk or formula, the black poop turns more yellow-green. Then, after another while, it transforms into something that looks like yellow cottage cheese. Yeah. But then, thankfully, the poop stops changing so much. At least until they start eating real food, and then all bets are off. It could be brown, green, yellow, a super dark shade of purple. One time, it was sort of whitish, and because I'm a new parent, I Googled it, which, of course, said there was a life-threatening issue, so I called the pediatrician, and they were like, "Did your baby eat anything white?" And I was like, "Oh, yeah, yogurt. Cool." Part of the reason for this rainbow of poop colors and consistencies, aside from what the baby is eating, is what the microbes in their gut are up to. Babies are born with very few microbes. We used to think they were born sterile, but recent research has found a few species of fungi in the guts of infants at birth. But in order to get a thriving, diverse microbiome, babies need to get microbes from mom, including through the birth canal, if they were born that way, and through breast milk, if they breastfeed. Over time, they accumulate more and more helpful bugs that can influence all sorts of things, from the allergies they develop to the weight they gain. And seeing what ends up in their diapers, and sometimes the back of their onesies, or one time my bare foot, it's a window into that development. Poop is a window into a lot of things, in fact. What we're eating, what's living inside of us, what's making us sick. It can grow our food and power our cities. Poop is definitely gross, but we as a society could all stand to be a little more comfortable with it. If we're open to its smelly potential, we could really help the planet. One poo at a time. It's not your fault you're disgusted by poop. You've evolved that way. The disgust you feel for poop, snot, mold, even things that aren't actually gross but remind you of something gross, like cottage cheese and raw oysters, that feeling is part of what's known as your behavioral immune system.
Like our immune system, a behavioral immune system is designed to protect us from things that can cause us harm. And rotten food can certainly make us sick, as can bodily secretions and other, slimy, icky things. So those tend to be near the top of the list of things that disgust us. And the idea is if you're disgusted by something, you're going to stay away from it. So that aversion can be a form of protection. My name is Bryn Nelson. I am a science journalist. My background is in microbiology. I used to be a microbiologist. I got my PhD at the University of Washington and then decided to do science writing instead. And Flush is my first book.
That is Flush, The Remarkable Science of an Unlikely Treasure.
Disgust is a really fascinating thing. I devoted an entire chapter to it. Now, of course, it can go too far. And one of the problems with disgust is that people who have a high disgust factor, there tend to be side effects. So they can be overly clean, and there's some overlap with obsessive compulsive behavior, for example. And our desire to be rid of any sort of possibly disgusting thing can also lead to sort of over-sanitation, which can have an impact on like autoimmune conditions, for example. And people tend to be more disgusted by people they don't know, foreigners. So people with high disgust sensitivity, There's also some correlation with like xenophobia, for example.
But first things first. What is poop made of? If you'd have asked me before this interview, I'd have guessed it was mostly leftover food. All the fiber and stuff that our bodies haven't fully digested. And yeah, that's some of it, but it's not the main ingredient.
If you take out the water content, so about 3/4 of it is water, actually. But the dry component of it, there's a pretty high percentage that's actually microbes.
Yeah, it depends on whose poop you're looking at, but up to 54% of your colon cobras could be living and dead microbes. This is the part where I tell you that I asked ChatGPT to give me a list of synonyms for poop. The funnier the better. That's right, the AI is out to replace our 12-year-old boys. Anyway, not only are your butt nuggets full of microbes, up to 100 billion of them per gram of wet stool, but one study found that almost half of the bacteria were alive. You are shitting microscopic living beings. Talk about dropping the kids off at the pool.
But that makes sense if you think about the trillions of microbes that live in our gut, right? So it's basically the sample of this sort of rainforest in miniature that's inhabiting our intestinal tract. So if you think about just the sheer variety that you would find in a rainforest, you find that in your gut as well. And, some of them are sloughing off, or some of them are, chomping out little bits and coming out for the ride.
After bacteria comes the leftover bits from your food. Most importantly, fiber.
Of course, that depends on how much fiber you have in your diet. But people who eat high fiber foods like cassava, beans, things like that, they're going to have a lot more fiber in their gut. And they're also probably going to have a higher percentage of microbes because the fiber is a food for the microbes, and it's going to encourage more growth.
Fiber also holds on to water really well, which is why a high fiber diet makes for an easier time rolling out the brown carpet.
Then you have things like nutrients. We're a fairly complete plant food, our poop, because we have a number of different nutrients in poop, such as phosphorus, nitrogen, potassium, things like that. So that's why poop can be such a great fertilizer for plants, right? Because it contains all of these nutrients that they need. And then there's going to be other little bits, probably some undigested bits of protein, fat, things like that. There might be some inorganic things that come along with food like sand, grit, things like that.
When your body is ready to bomb the porcelain sea, two different muscles ready the cannons. Your inner and outer anal sphincters. The inner one isn't under your control. It's operated by the autonomic nervous system, the same one that keeps your heart pumping. That system will contract or relax the muscle based on the amount of pressure and volume being sensed down below. Luckily, you do have control over the outer muscle. So when you feel that inner sphincter begin to give way, you get the feeling that it's time to head to the Oval Office. The size and consistency of what comes out all depends on your diet. But there have been some truly record-breaking shits throughout history. And we know because they're fossilized. A fossilized turd is called a coprolite. And my very favorite thing that I have learned in making this episode is about the Lloyd's Bank coprolite. It was discovered by paleoscatologists, a real thing, in York, England in 1972. This poop dated back to the Viking times and measured, please get ready for this, 7.5 inches long and 2 inches wide. So like 1.5 Red Bull cans. It was also chock full of parasitic eggs. The person who passed this thing was not a Gwyneth Paltrow paragon of gut health. But even so, you have to imagine that this particular poo was unique enough to be one that they'd remember for years. At least, I really hope so. Anyway, in addition to the ingredients and appearance of your chocolate dragon, is the smell.
A lot of smell that makes up poop is the result of metabolism of the microbes that live in the gut. So the bacteria, the archaea, they, as part of their life cycle, are, chomping away on the extra bits in our guts. And then they're breaking down some of the amino acids and other compounds. And a lot of the smells, these volatile organic compounds that are released, kind of this invisible cloud around us at all times, a lot of that comes from the microbes that live inside us.
No two people have the exact same microbial community in their guts, but family members, and even just people who live together, have more similar microbiota than strangers. So if you've ever wondered why walking into the bathroom after your partner or roommate has painted the town brown isn't quite as bad as walking in after a stranger at Starbucks, that's probably one reason. Which brings up one of Bryn's favorite studies.
They did this trial where they smelled the diapers of babies, and they were asked to rate how disgusting the diapers were. What happened, though, is that they switched them up so that they then did like a blind test so that they didn't know which diaper was their own baby as opposed to someone else's baby. And both times they rated their own baby's poop as less disgusting than that of other babies. So there are a couple of ideas of how that works, but one of it is habituation. The first time that you have to change your baby's diaper, and I heard this again and again and again from parents. It was so revolting. It was the grossest thing that they had ever done. They were dry heaving, just they couldn't get through it. And then over time, they acclimated, right? Because you're taking care of a child. You have to. It also suggests that part of it may be the microbiome that we share. We share a portion of our microbiome with different people that we live with. And so maybe there's like a familiarity of the smell that is somehow more familiar, less disgusting.
So the reason you rarely gag at the smell of your family's poop, your partner's poop, or your roommate's poop is probably habituation. You're used to it, both because you smell their toilet torpedoes regularly and because you share microbes, which means it kind of smells like the booty bomb you're most used to smelling, your own. Of course, the microbes in your gut aren't just there to produce poo-pourri. They do a lot of different things. Some help you digest food, some produce important brain chemicals, seriously, and some just sit around and vibe. And because every microbiome is a special stinky snowflake, there are tests you can take to find out which microbes live inside of you. Bryn has taken one, though he stresses it was just for shits and giggles.
These tests are still sort of a rough indicator. There are still microbes that we don't know the identities of. So this is not necessarily a diagnostic thing. This is something that you can do kind of for fun and see what's going on inside of you.
Bryn used the Flore microbiome gut test from Sun Genomics, which asks you to send a, quote, micro stool sample in a prepaid mailer. Once you drop your deuce in the mailbox, you wait 1 to 3 weeks as Poo PhDs sequence your microbial DNA and post the results to a password-protected website and mobile app. So, what did Bryn find out?
I found, I think it was about 180 different types of species that were identified in my gut. Researchers still don't know what many of them actually do. So if you look them up, they'll say, identified from the poop of a healthy 25-year-old. And that's it. That's all we know. So they kind of slap a label on it, like, okay, well, it's probably not good or bad. It's probably just sort of like hanging out and metabolizing some sort of a carbohydrate or fiber substrate. They don't know. But what's fascinating is that even the microbes that we do know can be good in some contexts and bad in others, because the microbes are going to take advantage of whatever niche they have, right? So if you're healthy and you have an intact intestinal tract and you have a good diversity of microbes, even some microbes that we would consider to be pathogenic, disease-causing, aren't necessarily causing trouble in your gut because they're being held at bay by the diversity of other microbes. So even things like E. coli, for example, and we often think of different strains of E. coli as disease-causing, but many strains of E. coli are actually harmless to us. And others, it depends on the context.
This kind of debunks the idea of good gut bacteria and bad gut bacteria. Like probiotics are supposed to populate your gut with healthy bacteria that improve your digestion and give you all sorts of other health benefits. But if it's more about the diversity of microbes than any one super microbe, how can probiotics possibly help? Well, Bryn learned the answer to that firsthand.
It was funny in a way. It was like I was cramming for a test, right? Because I wanted to have this great score, high biodiversity. So I was eating yogurt, but I was also taking a probiotic that had, I think, 10 different strains in it. And what was fascinating to me is that when I got my sequence results back, one of the strains that was in the yogurt showed up, but none of the 10 strains that were in the probiotic showed up. And so part of that is that you don't know when you're buying a probiotic how many of the strains, even if they're all in there as advertised, how many of them actually survive through your stomach to get to your intestinal tract.
Because think about it. If every microbe we ingested could survive the whole trip through our digestive system, we'd be getting sick constantly. Instead, there's stomach acid, which kills off most of the microbes in our food to protect us. Only certain microbes can survive that acid bath.
There are ones that are adapted to living in the gut. So it makes sense that some of the strains that you would find in yogurt are the same ones that you find in the intestinal tract of infants, of babies, because part of what they're doing is breaking down milk, lactose. And so some of these are in the yogurt cultures. So that made sense. But yes, it did bring a new skepticism about all of these supplements that you have on the shelves. And they're all promising, to do these wonderful things for your body. And at the end of the day, most of the advice can be boiled down to eat whole foods that have a lot of fiber, because fiber is good for you and fiber is good for the microbes in your gut, and then eat fermented foods. So I think, whenever you have the choice, eating it in the context of a food is always a better choice.
But in Bryn's microbiome results, he did have one red flag. Clostridioides difficile, or C. diff.
This is one of those bacterial infections that you can get in hospitals. You can get in other places as well, but it's a hospital-acquired infection. And it can destroy your intestinal tract. It's very horrible. But basically, it was sort of a shock for me to see that in my gut. And so I, called a number of researchers and said, what does this mean? Should I be concerned? And it turns out that an actual good percentage of people are asymptomatic and carry this particular microbe transiently for, some period of time. But again, because of the diversity of other microbes in our gut, they're kind of holding it at bay. So we never get sick from it. And it's only when there's a disturbance, if you take a particular type of antibiotic, for example, and it may kill off many of the other microbes, but not this one, then that becomes a problem. So it was really interesting to think about. And even this one microbe where I had a little bit of a freak out over it, I was in the end kind of reassured because of the diversity of this sort of rainforest inside me. The other microbes were kind of keeping this in check.
If Bryn's other microbes hadn't kept that C. diff in check, he'd be in the same boat as around 460,000 other people each year. Clostridioides difficile is often picked up in hospitals, and it's quickly becoming resistant to our first-line antibiotics. So it's really hard to treat. One way you can treat it, along with a number of other unrelenting conditions like Crohn's disease and ulcerative colitis, is by repopulating your internal rainforest with helpful microbes. And you can do that with a fecal transplant.
So fecal transplants actually have this very colorful history. It goes back way longer than most people would think. There's actually some evidence of it in 4th century China. In that context, though, it was actually an oral sort of suspension that people drank. Yeah, so talk about gross. It was refined over the years, but if you go back and you look at some of the benefits of that, they actually track with what we know some of the benefits are now. So people who were having horrible intestinal issues were able to find relief from this. And it makes sense because if you're having an imbalance in your gut, if you're able to do this transplant, essentially, from someone who has a healthy gut and everything's in balance, it can essentially reseed your intestinal tract, basically like crowding out the weeds in a garden. And so this started being this kind of folk remedy that people were going to for different types of afflictions. And the most common one was this bacterial infection, C. diff. At the time, probably like in the 80s and 90s, where it was just kind of getting off the ground, doctors did not want to do it. They hadn't heard about it, and many of them were disgusted by it. They thought it was quack science. So many people resorted to DIY therapies, basically using an enema kit. And miraculously, a lot of them got better.
I am now going to point out that a DIY fecal transplant is very risky. Even if the poop is from a healthy family member, it could contain pathogens that could make an already sick person extremely sick, even if it doesn't have an effect on the original donor. Fecal transplants performed in a medical setting are done with donor stool that's gone through a lengthy screening and testing process. And even then, people have died from improperly tested fecal transplants. You don't want to mess around with this stuff.
But what happened was people started doing research on it and were kind of amazed that if you did this with properly screened donors, you could have this unbelievable cure rate that was far above anything that doctors were seeing. So cure rates of like 90% for people who had this infection repeatedly. And that's almost unheard of. So then science started taking it seriously. And then the question became, okay, well, how can we refine the method of delivery, right? Because it's, you're basically transplanting someone's microbiome in the context of poop through an enema, or better, through like a colonoscopy kit, because you want it higher up in the gut. But still, that's an involved process. It's not terribly palatable. So now people are looking at like triple coated capsules so that it survives the trip down the stomach. They're looking at other things. Can we actually isolate the microbes that are causing the benefit of this? And that actually turns out to be a trickier thing than most people would realize, because it's really hard to say, well, it's just these 10 species. Because again, everything is interacting with everything else. And they've made some progress towards this. And there was the first FDA approved version of a fecal transplant for this. But it's been really difficult to kind of narrow down, like, what's the secret sauce for this? But it's been just a fascinating evolution of this therapy. And a fecal transplant isn't going to do everything, but for particular conditions, and even for some autoimmune conditions, it does have a lot of promise.
Who knew that the shit within you had the potential to heal another human? But that's not all your ass apples can accomplish. For centuries, people all over the world have been using human waste for all sorts of things.
Indigenous cultures all over the world have recognized the value of poop as a natural product. This is something that animals produce naturally, and it's part of nature's recycling system. One of the examples was in the Amazon, where they found these patches of very fertile earth. Most of the Amazon, the soil isn't as fertile as you would think. But in these places, and they call them terra preta, or dark soils, they have found much higher carbon content in it.
Historically, the Amazon didn't have large livestock like cows to provide food. Instead, locals had to rely on local fruit, small animals and fish, and just growing their own. But without big animals for fertilizer, they had to get creative. Researchers think these super fertile areas came about by indigenous residents mixing their own poop with other organic waste from their food and small livestock, plus burned bits from their fires, which contain a lot of carbon.
Carbon can be created by heating plant material or other organic material over high heat and low oxygen. So think of them as like our charcoal briquettes that we use for barbecuing. But in little crumbly bits, they can actually retain a lot of moisture, and they can make soils much more fertile. So this combination of this biochar is what it's known as, plus this organic material created these incredibly fertile places. And so that has completely rewritten the history of how many people these areas could have supported. And so in the past, scientists were very dubious that there were a lot of people. And now they think that there could be almost like these garden cities where people were contributing back to the soils, enriching them, and then able to grow an abundance of food.
There's also the historical practice of collecting what's known as night soil, or in Japanese, shimogoi. Farmers in the areas around cities would literally buy people's shit to fertilize their crops. And it was big business. Oh, but you didn't sell your own toilet gold. Your landlord laid claim to that. They set the prices on both ends, as it were. They charged farmers more for rich people's poop, which had more nutrients, and charged tenants higher rents if someone moved out, since that was one less poo producer on their books. To paraphrase Adam Smith, the landlords love to reap where they never sowed and demand a rent even for the natural produce of the butt. Anyway, this was a popular practice in China, too. Crap was valuable, and they put it to use.
It's really kind of us in the Western world and in Europe, where at a certain point we were like, ew, no, take it away by any means necessary. And we effectively squandered the potential.
But things are changing. People are realizing that our dingleberry delight, come on, ChatGPT, get serious. People are realizing that our waste is full of benefits, not only for our economy, but when it's used right, for our planet too.
Wastewater treatment plants have tried to reinvent themselves in some ways as resource recovery facilities. So this is this kind of little quiet transition that's kind of bubbling away under the surface. Not a lot of people know that this is happening. But a lot of wastewater treatment plants now are creating a pretty surprising number of different products.
One of those products is known as biosolids. I know, it sounds like the grossest euphemism for butt cake batter. Jesus. But it's actually cleaner than raw poop.
Biosolids is sort of the name that we give the organic material that's left over after wastewater treatment, right? And so a lot of people are instinctively grossed out by that. Biosolids gross. But what you're basically talking about at that point is just bacteria, because the living ones are consuming the dead and the rest of the organic matter. And so what they're doing is just successively transforming one type of matter to another and just sort of breaking everything down. That's the way that nature works. That's the way that nature's worked for millions and millions of years.
But even once you have those biosolids, they're processed again to create fertilizer to grow our food.
How that's done is you're treating them with high heat or high pressure or other mechanisms to kill the pathogens. And then what you're left with is essentially this sort of microbial slurry or other organic matter, but that's what plants love. That's what they want. And so you can basically do a composting process. Some places do composting. I tried this in our garden and our plants went crazy. And it's basically at that point, it's almost like dirt. It's a soil amendment because that's what happens in nature. You know, organic material breaks down and over time it becomes soil. So this is just kind of speeding up that process.
Is it the same as using like cow manure? I mean, do they do the same things to livestock manure when they turn that into fertilizer? Is it the same process?
I would argue that for human manure, that it is actually more treated and that they're actually doing more things to ensure its safety. And part of that is because, again, you have this sort of disgust factor. Like people don't have a problem with cow manure on farms. I mean, they've been doing it for forever. Chicken manure, other types of animal manure. That's always been seen as a commodity. It's only our manure that we say, oh, gross, this is awful, we can't do this. And there are some legitimate safety concerns. You clearly don't want to get people sick either with, pathogens or chemicals or things like that. So there is a regulatory burden on making sure that people are testing for all of the bad things that can make us sick. And I think that, that transparency is crucial for convincing people that this is a safe thing. But yeah, there's a lot more regulations for this type of biosolid-based fertilizer than there is for like manure or other types of compost. And I think that makes sense. But I think people don't understand that. And they think that, oh, well, wastewater treatment plants are just sort of like dumping this raw sewage on farms. Isn't that gross? And, people are getting sick.
In the process, these wastewater treatment plants are also extracting phosphorus, which is essential for plant growth. It's what plants crave. But because plants love it so much, you want it controlled. Too much in the environment and you'll have huge algae blooms, which use up all the oxygen in the water and kill off fish and other aquatic life. But turn it into fertilizer pellets and sell it to farmers, and you're keeping it out of the waterways and helping us grow food. It's a win-win. In addition to biosolids, wastewater treatment centers are also collecting biogas. Farts. It's farts. Okay, fine, methane.
If you have archaea, microbes that live in your gut, they will produce methane. So not everyone has the type of archaea that produce methane, but many of us do. But what happens is if you can create a system at a wastewater treatment plant that kind of mimics the conditions of the human gut, so no oxygen, because these bugs don't like oxygen, and you're basically kind of creating a giant vat of these microbes, and they're feasting upon the waste, which is organic matter. And as a result, they're producing byproducts, one of which is methane. And we have learned how to capture that and purify that into biogas. Biogas can be used for electricity. Biogas can be used to power buses. So in Oslo, where I visited, they actually power a percentage of their city buses with biogas from wastewater treatment plants. So that's an incredibly valuable resource that before was just going up into the atmosphere because we would bury a lot of poop in landfills. And then the methane gas from the natural decomposition would just seep up and end up in the atmosphere. And methane is a greenhouse gas. So this is kind of closing that loop and is actually way more efficient as well as way more environmentally friendly.
The more we push through our disgust and realize the potential that lies in poop, the more we can engage in really creative solutions to grow our food, power our cities, and save our planet. Part of this involves facing up to the fact that we're animals living in our environment just like any other, and we're a part of that environment.
I guess my parting message would just be that I hope that this starts a long-lasting conversation about our place in the natural world. And we kind of divorced ourselves from that for a while. And, we used chemicals and we used kind of all these other things and we hid these products. And I think now there's this welcome movement back to reclaiming our role as producers and understanding that in the right way, we can have an enormous impact on some of the big problems facing us.
Thanks for listening. Big thanks to Bryn Nelson. Again, his book is Flush, The Remarkable Science of an Unlikely Treasure. You can find a link to pick it up in the show notes. Taboo Science is written by me, Ashley Hamer. The theme was by Danny Lopatka of DLC Music. Episode music is from Epidemic Sound. If you need music for a project, use the referral link in the show notes. It helps. If you liked this episode, it would be great if you could give the show a review in Apple Podcasts. There's a link at the bottom of the show notes that'll take you straight there. One fresh new review from Jairus CD says, "Excellent science journalism on topics that are not covered anywhere else. Ashley is fun and engaging, the research is great, and the voice of Aglet at the end is the cherry on top of this podcast Sunday." Thanks, Jairus. I know it can be hard to think of what to write in a review, so if you want to leave one, try this. Tell me either the first episode you ever heard or where you heard about the show. Or both. Up to you. I might read it on a future show, so, it's worth it. The next episode will be out in 2 weeks, and it's all about breastfeeding. Oh, so much cool stuff you don't even know. You're not ready for this. Oh, also, I have a new sign-off. Ready? Here we go. Tune in next time. I won't tell anyone.